All right, what's going on, guys? So, one of the times that we did yesterday was dealing with charge interactions. So, based off of some of our notes from the last couple of days, all right, we had a couple different things going on. We had, all right, basic things that we should know by now. Okay, neutral atoms contain the same number of protons and electrons. Protons are positive, electrons are negative. Only the electrons can move, all right? So they're the ones that are allowed to move to create an unbalance. If you have more protons than electrons, you're positively charged. If you have more electrons than protons, you are going to be negatively charged. All right, more electrons, negative charge, less electrons, all right, you'll wind up being positive. Like charges repel, so two negatives. When you have two negative charges brought kind of close to each other, yeah, they don't like each other, so they're going to repel. Opposite charges, they will attract, so a negative and a positive attract. Another thing is, all right, if we have a neutral object, so just there's no charge on this one right here, a neutral object will always be attracted to a charged object. So it doesn't matter if it's negative, they will attract, or if it's positive, they will attract. Neutral objects will never repel anything, but if you have two neutral objects and they brought near each other, nothing's going to happen. All right, so those are your basic charge interactions. Friction can be created by rubbing two things together. So if originally both of these pieces of paper are a piece of paper and the tennis ball themselves, we rub them together. They're both neutral. All right, we rub them together. If the tennis ball has a stronger attraction, the material that it's made of has a stronger attraction for electrons than the paper, the tennis ball rips some of the electrons off the paper, giving it more negative charge, electrons. So now it's overall negative. This, all right, got electrons taken away from it. So now it's going to be left overall positively charged. Okay, that's how certain things work on this little kind of static electric series that we have. Looking, down here, you can see many different charts, but according to how it goes, these guys tend to lose them, these guys tend to gain them. So these guys are stronger than these guys. So silicon down here is stronger than everybody above it on this chart. So if I, let's say, rub silicon with paper, silicon's stronger. Just like the tennis ball took electrons away from the paper, the silicon would become negative and the paper would become positive, or the cotton would become positive. Well, actually, any of them above it. All right, so that's how that kind of good works. A conductive material, electrons are allowed to move around the whole thing. Right? If we rub, let's say this is a insulative material where electrons don't really move freely. If we give this a static charge by, all right, let's say friction, a lot of the charge is going to stay on this area, in this area over here, this little spot. But if this was a metal sphere, the electrons could move around the entire thing. They would spread out evenly across the entire thing. Okay. Then we're going to take just a quick peek at what grounding is. So grounding, if I can just give us this little picture here, how grounding works. This little wire is a symbol for grounding, and grounding is going to basically be a pathway that is provided by our, excuse me, there we go. Grounding is basically a way to remove a charge, in a sense. By providing a path to the ground, what can happen is electrons can either move from this object to the ground to try and neutralize itself, or it can come up from the ground to this to try and neutralize itself. Or there can be other forms of, well, I'll show this when we get right into induction. But let's see real quick one of the other methods of charging. Yeah, all right, let's go with this then first. Okay, a transfer of charge without touching. So the side of the object that is closest to this charging rod is going to receive the charge opposite. So the way we can show that is where is it? Okay, so here a negatively or positively charged object is brought near a neutral conductive sphere. The electrons are attracted to this positive charge. So they, scoot over towards this side. So now this side over here becomes more negatively charged, and then this side over here becomes more positively charged. Okay, so then when they created a grounding path, right, our hand touching this, the electrons are attracted. Remember, this side is more positively charged. So we have electrons that are attracted to that. So they will come up from the ground and they will try and add themselves a little bit here. So we're going to gain some electrons, some negatives. And then as soon as we take our hand away, now we're going to have more negative charge in here than we did originally. So induction, charging by induction is going to wind up giving us the opposite charge. So we bring a positive balloon over here. The electrons are attracted to it. They slide over. We provide a path to the ground. They're attracted. All right, I know we said this side was positively charged, so the electrons we could say that they're attracted to this side, or they're even attracted to this positive charge all the way over here. Either way, right, the idea still holds. Let's get rid of that. And then let's look at the other side of that. We bring a negatively charged balloon over here. These electrons do not like it. Like charges repel, so these electrons scoot over this side, which makes this side more negatively charged, this side more positively charged. Now, when we touch the wire and make a grounding wire, these electrons that were over here, these negative charges, they want to get as far away from the balloon as possible, because this is a lot of negative charge. So they want to go as far away to the right. That is not a good arrow. They want to go as far away to the right as they can. Now, when we provide a path to the ground, well, guess what? They can keep moving. So that's what they're going to do. They're going to want to keep moving. And then when we take our hand away and let go, now we're left overall positive charge. So induction is going to give us, all right, the opposite charge here. Now, another thing would be if we come close to the object right here, we kind of separate the charge. One side is going to be more positive, one side is going to be more negative, and we don't make contact with the balloon, or we have a grounding path. Then as soon as we take the balloon away, it goes back to being neutral, same number of positives and negatives. But if we go conduction, all right, conduction is going to be when they make actual contact, the charged, whatever the charged object is, if this is negatively charged and it touches this object, some of these extra electrons are attracted to the charge on the object over here, this extra positive charge, where it's not extra, it's neutral, but since there's a lot of negatives, they are attracted to some of that positive charge. They'll jump over. We take the rod away. They will be both negative. And then what would happen is, okay, if this was negative still, and now the ball is negative, let's say it's hanging on a string. Well, if they're both negative now they're going to repel. They're going to want to go away from each other. If they were, before they did that, if this was all negative, and you had the object that was neutral, well, the negatives in the object want to go to this side because they do not like this charge, which left this side positively charged. And if this ball was on a string, the ball would be attracted towards it. It would swing, right? So neutral is attracted to any charge. The same thing would happen with the positively charged rod. It'd just be reversed. The negatives would be over on this side, on the left side of the ball, neutral ball, and they would be attracted. If it made contact, all right, what's going to happen? Same thing. Positively charged rod. Some of these electrons are attracted to the extra positive charge in the rod, so some of these electrons jump over. And then when you remove them, now there's less negatives over here, so now you have a positive object and still a positively charged rod. Okay, so then we kind of went into looking at this thing here. We already said protons are positive, electrons are negative. Protons can't move, only the electrons. Opposites attract, like charges repel, and neutral objects will attract to either positive or negative, but they will never repel anything. So here, all right, the only thing you can tell for certain is that one of them has a charge. You can't say that they're both opposite because we don't know, but if one of them was positive, this could be neutral and they would still attract. This could be negative and they could still attract. We could also say that this is negative and over here is neutral. They would still attract. Or this is negative and over here was positive. They would still attract. So you know that at least one of them is charged and the other is got to be the opposite charge or neutral. That's the only one you can say for certain. Here, they're repelling each other, so they both have to be the same. So they both have to be minus. All right, they both have to be negative, or they can both be positive. And then this last one can't actually happen. Even if this was neutral, if they're both just hanging from a string, if they're both just hanging from a string and it's not like being held down by anything, yeah, they're both going to be attracted to each other. If one of them is positive, or I'm sorry, if one of them has a charge, remember it could be positive or negative, and then this thing is neutral, they would both have to be attracted towards each other. So like, that's the only way that can happen. All right, that's the only way that that can happen. Then we take a look at this. Like, so there's little bits of paper here. So with these little bits of paper, paper's neutral. This balloon was negative. They said they brought an object near it. Object A brought near the paper bits. All right, well, all you know is that if it attracts the paper bits, it has to have a charge. It could be positive or negative. The second object attracts the balloon. Well, it could definitely be positive because opposites attract. But it could also, if this is the other object, it could be positive or neutral, and there would still be an attraction here. Object C was observed to repel the balloon. So the only way these two things would repel each other is if it had the same charge. So this thing would have, whatever this object is, it would have to be negative. Object D attracts paper, so it would have to be either positive or negative, but then it also attracts the balloon. So it has to be positive because if it was negative, it would not be able to do so. E, it attracts paper, so it has to have positive or negative charge, and then it repels the balloon. A positive charge would not repel the negatively charged balloon, so therefore it has to be negative only. A and B, you know, if the only one you know for sure in all of these is that B is negative. So right off the rip, C 100% has to be negative because they're repelling. A could be positive or neutral. B is negative. Okay, so A could be positive, right, or neutral, but when we bring it over here, it's repelling something. A neutral object never repels anything, so that option goes away, which means A has to be positive, and therefore C also has to be positive. All right, and then here, again, we knew that B is negative. They are attracting, so this would have to be positive or neutral for object C. So if this was positive or neutral, if A was negative, it could attract either of them, right? But let's say, just for the heck of it, C wound up being positive. Well, A could therefore then be negative or neutral. So we don't know, but these would be the options. It could be negative or neutral for A, and it could be positive or neutral for C. In this one, you only know that A is negative and B is neutral. Remember, to repel something, it can't be neutral. It has to have the same charge. Like charges repel, opposites attract. Neutrals can still be attracted to the other charges, but it can never repel. So we start off with A being negative. Okay, it attracts F. So we said F could be positive or neutral. But in the next thing, F and D, they repel. So it can't be neutral. So we would have gotten rid of that. And they would have to be the same charge, positive and positive. Object D is attracted to E. So D could be negative or neutral if E is positive. And then we look at the next thing, D and C are they repel. So if this was possibly negative or neutral, but you see that C and D repel, then you can't have neutral as an option because neutral never repels. So this is what you're left with here. And then kind of looking at this, all right, you have a negatively charged object here. What's going to happen? The negatives in this neutral can want to go to that side, leaving this side positively charged. Again, negative. All right, you provide a path from here to the ground. These negatives want to get as far away from this negative charge balloon as they possibly can. So when you make a grounding contact, some of the electrons are going to get farther away. The electrons are going to go farther away, and that's going to leave the can overall very positively charged at the end. This is known as charging by induction. Before it makes contact, remember the balloon is negatively charged. The negatives in the object are going to want to go farther away because they're repelled, so it would be like this, object B. Now when the soda can, right, when the soda can is touched by the hand here, all right, remember, only the electrons can move, so A and B are definitely not options. So the electrons are going to go from the can through the hand to the ground, and then we remove it, and we're going to be left with a positive charge. Charging by induction, the object is going to get the opposite charge of the charged object we put near. So if we brought a negative here, do this little method here with the touch the ground, all right, it's going to wind up receiving a positive charge, and then if it was a positively charged balloon, it would wind up being negative, which is kind of what's going on in the back. Positively charged balloon. The electrons in here are attracted to it, so they go towards the left side of the can, which leaves the right side overall positively charged. All right, negative and positive. So we make a path to the ground. This right here is positively charged. So if we're making contact on this side, we could say that the electrons are attracted to that. So we get some extra electrons added in. So we're going to get some little extra negatives that we didn't have before. And we remove our hand. And then what would happen is the can would be left overall negatively charged. It receives the opposite charge of the charged object we brought close to it. Again, so we have a positively charged balloon. Remember that we can't say that the positives or the protons repel themselves away. I mean, technically, lots positive charges don't like each other, but only the electrons can move. So it's the electrons that come over closer towards this side. Since not all the protons can move, some of the protons that are kind of stuck in place are still left over here. It's not that they ran over to the right side, but all the negatives came over to this direction. So that's why we have A here. All right, and then again, protons cannot move, so A and B are eliminated. and the electrons go from the hand to the can. From the hand to the can. See. And this process caused the can to get a overall negative charge. And then this polarization method here. All right, they bring a negatively charged balloon here. So what's going to happen is, yes, there were some positives and negative charge. These both were neutral. They're just touching. Nothing's going on. You bring a negative charge over here. The overall electrons from both cans are going to slide over this way. So that's going to make this left side negatively charged overall and the right side more positively charged. And then when you separate them, well, that negative charge was still closer over here, and this side would be more positively charged. This is, again, charging by induction, and that's kind of what's going on with the polarization of this. Polarization is the molecules themselves are kind of orienting themselves in a different way, where the negatives are more attracted towards that. I'm sorry, was this? I have this reversed. This was a negatively charged, so I apologize. If this was positive, that's exactly what would happen. I could not see on this little guy, so this is negative, not positive. Okay, so here we go. The electrons do not like this, so they're going to go to this side, making this can negatively charged, and this side positively charged. And then when we kind of move them off each other, this side would be left more positively charged, this side would be left more negatively charged. Okay.